Okay, today we're going to be working on just kind of solidifying our knowledge in the unit circle and just the different things that are involved. One of the things I want to start with is kind of deciding, why is this picture funny? What is kind of a cute little play on words here? And it's sine B over tan B, and what they're showing is that it equals the comedian and actor Cosby. Is it William Cosby? Bill Cosby, yeah. So let's do. Oh, sorry here, guys. There we go. Um, so I want to look here, and I want to remind you from past things that tangent, any tangent, that our tangent equals sine over cosine. All right, if we know that, we can switch tangent and cosine around. So then cosine equals sine over tangent. Well, that's funny if you say, well, it's sine B over tan B, and then that equals cos B or cosine B. So that's why that is kind of funny. All right, let's move on. This is our goals for what we're going to really do, and I'm really going to be looking at the 6 values of the trig functions here. So I want to talk first about where is cosine positive. Kind of talking about just theory here. Cosine, if you remember, is your x value. So we're really asking ourselves, where is x positive? Because if wherever x is positive, then the cosine will be positive. X is positive, excuse me, I have the wrong direction here for a moment. X is positive as you go to the right. So cosine is positive in the first and the fourth quadrant there. Now let's look at the next question. In which quadrant is the sine positive? Sine goes to the y. So we're asking ourselves the question, where is y positive? Where is y positive? All right, we're asking ourselves that question. Well, y gets positive in this first and the second quadrant. So sine is positive here in the first quadrant and the second quadrant. Now the last question we're going to ask is, where is tangent positive? If you remember, tangent is y over x. And so in order for that to be positive, we either have to have a positive divided by a positive, or we're going to have a negative divided by a negative. Well, positive divided by a positive would be here in the first quadrant. That would give us a positive. And then in the third quadrant, tangent would also be positive because we'd have a negative divided by a negative, which would result in a positive answer. So one way that we've used in the past to kind of just be a genius about this and remember it is this statement, all students take calculus. And it's just a reminder of where, in which quadrants do we have positive values. And so the idea is that sine, tangent, and cosine is all positive in the first quadrant. All right, so sorry, I don't want to have said it's all there. So it's going to be all in the first quadrant here. Here in the second quadrant, only sine is positive. Third quadrant, tangent is positive. Fourth quadrant, cosine is positive. All right, so now, where do we have things undefined? We need to kind of talk about this. Let's start with, I want to move things a little bit here. Let's start with just our coordinate axes. And these quadrangles can be difficult, fun word, but difficult concept at times. All right, so let's look at quadrangles there. First of all, let's talk about what are quadrangles. It's the idea that we have here a 0 degrees or 90 degrees. All right, so we can call this 0, or not 90, sorry, 360. I'm talking and thinking of two different things. Here it's 90 degrees. Here we have 180 degrees. And down here it's 270 degrees. You just kind of have to memorize or just realize that when you're dealing with a value that falls right on an axis, we're dealing with a quadrangle. And the best way to deal with these is to think of them as the actual points. So this is the point 1, 0. Remember that we have the unit circle, so that makes sense hopefully that this is a unit right here. Here is the point 0, 1. At 180 we have the point -1, 0. And then at 270 we have the point 0, -1. All right. Now, knowing that, we're talking about where are things undefined. In other words, they don't exist. With cosine, cosine is really just your x value. Is there anywhere here where our x value doesn't exist? You know what? No, you can find an x value here. You can find an x value. Even if it's 0, there's always an x value. So there is none. Same thing with sine, which is our y value. So for both of these, there's nowhere. that it doesn't exist. So the answer to that question is nowhere. Everywhere it exists. So I'm going to say nowhere for both of them. However, that's not the case with secant and tangent and, tangent, secant. I'm going to bring tangent down here. Let's see if I can do a little bit better here. Okay, where is tangent? We're going to do that. Where is tangent undefined? Okay, let's think about that now. Where is tangent undefined? I think of tangent as y over x. Okay, so if I have y over x here, your denominator can never be 0. So you're going to say x can't equal 0. So where does x equal 0, meaning it's going to be divided by 0, which you can't, is in the on the y-axis. So at 90 degrees and at 270 degrees, that's where tangent will be undefined because the x is equal to 0. Well, the same idea holds true here for, excuse me, oh, I don't know why I'm not, there we go, everything not working for me there. The same idea holds true for secant, because in secant what you're doing is you're taking 1 divided by the x. So the same idea, you can't have x equal to 0, and that means it can't be on this, oh, that's a terrible y-axis here, my y-axis here, okay? All right. All right, so now we're going to talk about where is that cosecant undefined. Well, the cosecant, if you remember, I keep grabbing the wrong marker, is 1 over y. So now we're looking for where is y not equal to 0, okay? So y is not equal to 0 now is on, is on the horizontal axis. So that's at 180 degrees and 360 degrees. Same rule holds true for cotangent because that's x divided by y. We don't want y equal to 0. And so again, we have 180 degrees and 360 degrees. Okay, so what we're doing here, I'm going to go back here, sorry. What we're doing here, I'm going to copy that here. I'm going to get like a better picture of this. So here we go. All right. So the rule, and probably want to write this down. We have here, we have the point is 0, 1. We're at 90 degrees. All right. Here, another quadrangle, we're at 180 degrees, and our point is -1, 0. Here, we're at 270 degrees. And our point is 0, -1. Here you can say you're at 0 or 360 degrees. I don't care. You're going to see them both ways. And the point that you're at is 1, 0. What I need you to know is that here we have tangent and secant is undefined or does not exist. I'm going to put DNE. Here, and that same thing goes down here. Tangent and secant does not exist, DNE. On the horizontal axis, it was cotangent and cosecant, or C's, all right? That one does not exist. Here again, cotangent and cosecant does not exist. So that'd be something good to write down. Now, we also need to talk about just comparing and contrasting our 2 unit circles. I did a Google search and just kind of look for pictures and images. You might see these. So some things I want to point out. Like here, what we're seeing here is radians. So you might have seen radians before. That's going to come up, in a few chapters, in another chapter yet, before we talk about radians. But a lot of times what we've talked about is we said, don't have your calculator in radians. It'll kind of mess up your answer. So that's radians. The other thing I want to point out are these ordered pairs here, that we have ordered pairs. We have like square root of 3 over 2, and then this is 1/2. That those are ordered pairs, and what that represents are these little points. We kind of talked about that as we were showing you the different unit circles in some different videos here. But I kind of wanted to point that out because it shows you what your x is and what your y is. If you know your x and you know your y, you can find your 6 trig functions, and that's the point I want to make here. So this is from like a follow-up worksheet. It had a 5-3 kind of follow-up worksheet, and it's posted on my Moodle site. And here we're given my square roots don't quite work. We're given an x and a y. Okay, given an x and a y, can we find the 6 trig functions? You bet, it's actually not difficult at all. We can find sine, cosine, tangent, and then pretty quickly we can find cosecant, secant, and cotangent. And we know how quickly that can be in just a minute. Sine, if you remember, is just our y. So all we have to do is write down our y value for that point. The cosine of this point is just our x value, so we write down our x value. The tangent of this point is, now this is where we have to do a little work. It is our y value, negative square root of 3 over 2. Sorry, there you go. Divided by 1/2. Well, we have a rule here that says if you have two fractions and they're being divided and they have the same denominator, you can kind of ignore the denominator. What you're really doing is you're kind of multiplying by the reciprocal. So on a technicality, what we just did there is we did this. We multiplied, instead of this 1/2, we multiplied it by 2 over 1. This 2 and this 2 reduces down to a 1, and so that's why in the end our answer is this square root of 3. This theory, though, works, where if you're really kind of dividing by a 1 there at the same time, or there's the same thing, you kind of have that reducing that you can do. So just so you know, whichever way you think of it, you need to know how to do that division of two fractions. So now what's nice about cosecant, secant, and cotangent is you're just taking the reciprocal or the flip of the fractions that you already made up for sine, cosine, and tangent. So here I'm just going to write 2 over square root of 3, and that's negative. Secant, I'm going to write 2 over 1. Actually, I'm just going to write 2 because putting it over 1 doesn't matter. Here I'm going to write 1, negative out in front of it, over the square root of 3. So it's a negative 1 over square root of 3. So I kind of thought of this as, hey, that has really the square, it's over 1, and I just flipped it. Okay? Same rule applies here for number 2, okay? Again, I'm finding my sine, my cosine, and my tangent, okay? And I'm going to kind of go over here. In fact, I need to move this over. Yeah, I can do that here in a minute. There we go. I'll do that one in just a second. And then I'm going to find my cosecant, my secant, and my cotangent. All right, we'll start with sine. Sine is my x, or my y value, excuse me, positive square root of 2 over 2. Cosine is my x value, negative square root of 2 over 2. Tangent, what I'm saying in my head, I have my y value, square root of 2 over 2, and I'm dividing it by my x value, negative square root of 2 over 2. Answer here is just a negative 1. Cotangent, it's still a negative 1. Here I'm flipping. And here I'm flipping. Now I had this question come up a couple of times in class. Is it okay to leave this square root in the denominator? Usually we say, no, it's not quite right. It's not exactly the way we like to see it left. But because there's so much reciprocals and flipping of fractions, we're just not going to get too worried about it in pre-calculus at Armstrong right now, that we're going to allow you to leave square roots in the denominator for this trig unit. Okay, it's not saying that that's going to work forever in every math class you take, but for us and for the purpose that we're working on right now, we're okay if you leave the square roots in the denominator. All right, we're looking now at number 3. You know what? I'm going to go ahead and just pause it, and you're going to see the answer here in just a moment. Okay, so there's the answer. All right, I'm going to move on. Now, I just want to go through some more of these problems. It was just more practice problems. I think it's good just to practice. All right, I'm going to zoom in a little bit here, make it a little easy for ourselves. 210. So it's about drawing the angle first. So 210 would be here, and I'm drawing my angle. In my head, what I'm saying, and I just drew it wrong. Sorry. I don't have the time to not draw it wrong. All right, I'm down here. All right, in my head I'm going 210 minus 180, and I get 30. So that tells me here I have a 30-degree angle right here, and this must be a 60-degree angle. So then here must be 1/2, and it's a negative because it's going down. This is square root of 3 over 2. Answer is sine is a negative 1/2. Go ahead and finish the rest of these. I'm running out of time, but the big things we're looking for is can you draw the reference angle? Do you know across from a 60-degree is square root of 3 over 2? Across from a 30-degree is 1/2. Across from a 45-degree is square root of 2 over 2. And then those quadrangles, those are super important. So if we look at number 4 with this quadrangle here, all right, we're looking at 0, 1. All right, and cotangent is x over y. There we'd have 1 over 0. You can't divide by 0. And so that one does not exist. Have a great day.